Hi everybody, in this video I'm going to go over an example of how to do a two-proportion z-test. Let's take a look at the example, and at any time you could pause the video and read it and try the problem on your own. So Great Britain has a great literary tradition that spans centuries. One might assume then that Britons read more than the citizens of other countries. Some Canadians, however, feel that a higher percentage of Canadians than Britons read. A recent Gallup poll reported that 86% of 1,004 randomly sampled Canadians read at least one book in the past year, compared to 81% of 1,009 randomly sampled Britons. Do these results confirm a higher reading rate in Canada? All right, so we're given a lot of information. What I already did in advance is I went ahead and I wrote the sample, the proportion for the Britons who read. So be careful here. It's saying 86% of 1,004 and 81% of 1,009. So that means you have to come up with the fraction on your own. So to do that, it's very simple math. 81% of 1,009, you could just do 0.81, which is 81%, times 1,009, and you'll get approximately 817. So the first fraction of proportion of Britons who read is about 817 out of 1,009. That represents our p hat. Therefore, our q hat is 192 over 1,009. That way, when you add them together, we get 1. In other words, if 817 read, that means 192 do not read. And then we do the same thing for the Canadians. We have a sample of 863 out of 1,004. That means 141 out of 1,004 do not read. Now, why did I convert it to fraction form? Because when we want to do a two-proportion z-test in our calculator, as you can see right here, we will have to enter the two fraction. You cannot enter a percentage. So first thing we're going to do is statistics, go to stat tests, and I'm going to go to a two proportion z-test. So you can see right here, it's asking me to go ahead and enter the first sample, and then I enter the second sample. Now, keep in mind, you have the opportunity to decide which is your first sample or which is your second. So going back to the problem, let's go ahead and decide which one we will use as the first versus the second. So then the question asks, do these results confirm higher reading rate in Canada? So the first I'm going to do is I'm going to write my hypothesis statement, and that the null hypothesis is that the proportion of Canadians is equal to the proportion of Britons. Notice I have a population symbol in my hypothesis statement. I do not write a p hat here. This is a p, meaning it's a population proportion. So when I state they are equal to right here, that is saying that they are the same, that there is no difference between the two proportions. Another way to write this exact statement is to just say that the proportion of Canadians minus the proportion of Britons equals to 0. In other words, their difference is 0. So these are two ways you can write the hypothesis for the null. You don't have to write both. You can choose either one. All right, for the alternative, I'm answering the questions. Do Canadians read at a higher rate than in Britain? So therefore, the alternative is going to test whether the proportion of Canadians is greater than the proportion of Britons. Now, you can actually do it the other way around. If you do it the other way around, then you have to say that the proportion of Britons is less than proportion of Canadians. And then you would reverse both samples. So for the alternative, subtracting both, meaning the difference is more than 0. All right, once I have my hypothesis statement, I can easily enter my information into a calculator and then get the p-value and all the statistics that I need. So I'm going to enter the first sample as the Canadian. So that will be 863 over 1,004. Now notice you cannot enter a percentage here, which is why we needed to convert the percentage to a fraction. All right, the second sample I'm entering is the Brits, which is 817 over 1,009. And the test we are going to check is that P1 is greater than P2. In other words, the Canadian reads more than the Britons, and then press OK. So our results are right here in the calculator. We can see we get a z-score, a p-value. Now there is one more thing that is new with this test. Otherwise, it is very simple to a one proportion z-test. The only difference here is we're looking at two proportions. And the way we look at our standard deviation is slightly different. So let's go ahead and look to see how we will do that. So looking at our results, which I posted right here on the right, we then go on to state and check the conditions. And stating and checking the conditions is exactly the same thing we do for a one proportion, but now you need to do it for each sample, so you do it twice. So here is an example of how you can do that. So looking at the conditions, both samples were randomly selected. That's what it states in the paragraph. Now the success failure condition, that is when we're checking that the, all right, we're gonna check the success and failure. This is basically when we are checking that our p hat in this case, because we don't know p, so p hat times n is greater than equal to 10. And then we're going to do the same thing for q hat times n is greater or equal to 10. So basically the results are written as in paragraph form. It's saying if we look at the first fraction, we have that the first proportion that we're going to look at is 863 over 1,004. If I multiply p hat times n, we're just left with 863. And then here, if I'm left with, if I multiply by n, we're just left with 141. So basically, we're just left with the numerators if we're multiplying by the same n. So looking at that, we can say that there are 817 Britons who read. That's greater than or equal to 10. That means 192 who do not read. That's also greater than or equal to 10. And then when we do the same thing for the Canadians, we get 863 and 141 who do not. And both values are greater than or equal to 10. So the success and failure are both larger than 10. And then the 10% condition is when we say that the population is greater than or equal to 10 times n. We're going to do it for both samples. In other words, we're going to do for the Canadian group and then for the Britain group. And looking at both, we see that there are more than 10,090 Britons, and there are more than 10,040 Canadians. All right, so now we're going to say what we're going to do, and that is conditions met. We will use a two proportion z-test. Notice I have the exact same formula for the mechanics. It's always test statistic minus parameter over standard deviation of statistic. Our test statistic is our z-score. Our statistic in this case is the difference between our two samples. So our p hat of Canadian minus p hat of the Britons who read. So take a look over here. We actually have our p hat written here, and we also have our p hat 2. This is the second one written here. So we're basically going to say the Canadian is 0.859562 minus the Brits 0.809713. That is the difference. So we are looking at P hat of Canadians minus Brits. So that is what I wrote here below. Now, minus parameter, that is actually the difference of the population parameter. So it's P of the Canadian minus P of the Brits, which actually, if you look at the null hypothesis, we said that was 0. We said there was no difference. So looking at what I wrote here, if you see that, this is why I wrote 0. Okay, that is the population difference of the two samples. Now, the new thing here is the standard deviation. As I mentioned it in class, because we are saying there is no difference between the two, then we pool the two samples together. In other words, here is my p hat pool. I took the first sample, which is 863 over 1004, and the second sample, 817 over 1009. I add the numerators and denominators together, and basically this p hat, the pooled amount, is what you see right over here. That is 0.834575. You could basically say that that's approximately 0.84. So I'm going to use 0.84 in the standard deviation for our success. So right here, when I look at the standard deviation, I wrote it in symbols here. So the p hat, q hat, this is the pooled amount. Same for the numerator for the first sample, and then I added to the second sample, same numerator. In other words, the pooled amount. So looking at it here, we have 0.84 times 0.16. Remember, it's success times failure. They add up to 1 over the sample size of the first sample, plus 0.84 times 0.16 over the sample size of the second sample. Now, this does look kind of messy. There are a lot of numbers. Basically, this is our z-score. That is our test statistic. And how did I get this 3.01? Well, I got it from the calculator. It is this z-score, 3.00965. So I basically rounded up to 3.01. And that is our z-score. And then I wrote down the p-value, which is 0.001308. So I rewrote that. We can clearly see this is a very small p-value. So our conclusion now is basically the same as what we would write for any t-test we have seen any hypothesis test we have done so far. We are going to mention first the null. We either reject or fail to reject. Now, since our p-value right here is small, smaller than our alpha, which is our significant level, we are going to reject the null. So we are going to state we reject the null since the p-value of 0.001308 is less than alpha 0.05. We have sufficient evidence that the percentage of Canadians who read is higher than the percentage of Brits that read. So I basically restate the problem in the conclusion. And then I drew a little picture to show you that our sample clearly fell in our rejection area. It was actually even further to the right. So anything in this red zone right here, if the difference of our two samples falls in this red zone, which it did, then we reject the null hypothesis. All right, so this basically concludes a two-proportion z test.